Welcome to this video in which we're going to talk about strategies for solving nonlinear equations so that by the end of this video you will be able to choose between the different solution methods that we have talked about so far. So the big question is, which method of the three that we talked about, the bisection method, Newton's method, or the secant method, which one of these methods should you choose to solve a nonlinear equation or nonlinear equations? Well, some general observations are that Newton's method is the fastest. By that I mean you need the fewest calculations in order to obtain a target tolerance. Next fastest would be the secant method, and the bisection method is the slowest by far. However, the bisection method always converges to a root if the initial interval contains an odd number of roots, whereas Newton's method and the secant method may actually not converge at all. So here's a recipe that I suggest that usually works. First, try Newton's method if you are able to calculate the analytical derivative. If you're not able to calculate the analytical derivative, then use the secant method. If this method fails to converge, meaning the tolerances or the estimated relative error does not fall below an acceptable threshold after a certain number of iterations, and now the number of iterations can be anywhere in the order of 50 to 100 iterations, then do the following. So if this doesn't work, then try the bisection method, either using it all the way or do some few bisection iterations and then try Newton's method or the secant method again using the results of the bisection method, the current solution. Now, how do you initialize the bisection method? The hope is that if your Newton's method or secant method was initialized close to the root, that in the process of updating using Newton's method or secant method, you will have found numerical solutions that had a change in sign. If you have that change in sign found in Newton's method or in the secant method, you can use those function values, those x values, as your initial bounds of the interval for the bisection method. Thank you for watching.